Hello everyone, welcome to session 2 of projection of lines. In today's session, we will discuss problems having case 2 in which end projectors of the lines are given. So let us start with the first problem. The distance between the end projectors of straight line AB is 60 mm. Point A is 5 mm above HP, 30 mm in front of VP. Point B is 40 mm above HP, 50 mm behind VP. Draw the projection and find the inclination of the line AB with HP and VP and true length of the line. So let us recall the given data. The distance between the end projectors of straight line AB is 60 mm. So end projectors, that is EP, is 60 mm. Point A is 5 mm above HP, 30 mm in front of VP. Point A is 5 mm above HP, 30 mm in front of VP. Above HP in front of VP. That means point A is in the first quadrant. Point B is 40 mm above HP, 50 behind VP. So point B is 40 mm above HP, 50 behind VP. Above HP, behind VP. That means we can say that point B is in the second quadrant. So draw projection of the lines. To draw the projection, that means to draw the top view and front view of the line. And find the inclination of the line AB with HP and VP. So we have to find out the true length of the line, that is TL. Inclination of the line AB with HP, that is theta. Inclination of the line AB with vertical plane, that is phi. So let us start with XY reference line, and as it is the example of N projectors, and N projectors are 60 mm. So measure 60 mm, mark the N projectors, draw the N projectors. Now point A is 5 mm above HP, 30 mm in front of VP. 5 mm above HP, that means the elevation of point A will be 5 mm above the XY reference line. So measure 5 mm above the XY reference line and draw locus of A dash. And it is 30 mm in front of VP. So the plan of point A will be 30 mm below the XY reference line. So measure 30 mm below the XY reference line and draw locus of A. We will get A dash on this locus, and we will get plan of point A on this locus. Now let us consider that this is the projector of point A, and this will be the projector of point B. So we will get A dash over here and A over here. So this is the elevation of point A, and this is the plan of point A. Now point B is 40 mm above HP. 40 mm above HP. That means the elevation of point B will be 40 mm above the XY reference line. So measure 40 mm from the XY reference line and draw locus of B dash. So this will be the locus of B dash, and we can also say that this will be also the locus of B1 dash, because B dash and B1 dash will be on the same locus. And it is 50 mm behind of VP. Behind of VP, that means the plan of point B will be 50 mm above the XY reference line. So measure 50 mm from the XY reference line and draw locus of B. So this will be locus of B and B1, because point B and B1 will be on the same locus. And now as this is the projector of point B, we will get B dash over here and B over here. Now connect AB will be our plan length, and the angle of the plan length is beta. And connect A dash B dash will be our elevation length, and the angle of the elevation length will be the alpha angle. Now we have to find out the true length, the theta angle and the phi angle. So if we want to find out the true length, measure AB, which is our plan length, and from A give an arc up to locus of A. So measure A to B and give an arc to locus of A from point A. The intersection point of this arc and this locus A will be B2. Now from B2 draw a straight line up to locus of B dash. We will get B1 dash over here. So this point is B1 dash. Now measure A dash B dash, and from A dash give an arc up to locus of A dash. Here we will get B2 dash. Now from B2 dash draw a straight line up to locus of B. So This point will be B1. Now connect A dash B1 dash will be our true length, and the angle of the true length is theta, and connect AB1 will be our true length at an angle phi. Now measure true length. True length will be equal to 103 mm. Measure theta angle. Theta will be equal to 30 degree, and measure phi. Phi will be equal to 45 degree. Now let us move on the next problem. A line CD has its end C 15 mm above HP, 10 mm in front of VP. The ND is 60 mm above HP. The distance between the end projectors is 50 mm. The line is inclined to HP by 25 degree. Draw the projectors and find its inclination with vertical plane, and also find the true length of the line CD. Now here we have changed some data, but we have given the end projectors again. So given data is point C is 50 mm above HP, 10 mm in front of VP. So point C is 15 mm above HP, 10 mm in front of VP. So above HP in front of VP, that means we can say that point C is in first quadrant. Now D is 60 mm above HP. So D is 60 mm above HP. The distance between the end projectors is 50 mm. So EP is 50 mm. The line is inclined to HP by 25 degree. So inclination of the line with the horizontal plane is considered as the theta. So theta is 25 degree. Draw the projection. That means we have to draw the plan and elevation length of the line, and find the inclination of the line with vertical plane, and also find the true length of the line. So we have to find out the true length and the angle of inclination of the line with the vertical plane, that is phi. Now here T is 60 mm above HP. That means we can say that above HP, that means D is in first quadrant, or it will be in the second quadrant. So first of all, let us fix the quadrant of point D. So assume point D is in the first quadrant. So assume point D in the first quadrant, and start the drawing with XY reference line. So draw XY reference line, and as it is the example of end projectors, so first of all mark end projectors at 50 mm distance. So measure 50 mm end projectors and draw end projectors of the line. C is 50 mm above HP, 10 mm in front of VP. So first of all mark C and C dash. So C is 50 mm above HP. That means the elevation of point C will be 15 mm above the XY reference line. So measure 15 mm above the XY reference line and draw locus of C dash. And it is 10 mm in front of VP. So the plan of point C will be 10 mm below the XY reference line. So measure 10 mm below the XY reference line and draw locus of C. So we will get plan of point C on this locus and elevation of point C on this locus. Now let us consider that this is the projector of point A. So we will get point C. So we will get C dash over here and C over here at this point. Now D is 60 mm above HP. 60 mm above, that means the elevation of point D will be 60 mm above the XY reference line. So measure 60 mm and draw locus of D dash and D1 dash. We can say that this will be the locus of D dash and D1 dash, because D dash and D1 dash will be on the same locus. Now as we have considered this as the projector of C, this will be the projector of D. So we will get D dash over here. So connect C dash D dash will be our elevation length, and the angle of the elevation length will be alpha. Now we have the theta also. So theta is equal to 25 degree, and we can say that theta is the angle of inclination of the line with the horizontal plane, and also the angle of the true length. And we can say that we can draw theta from C dash. So measure 25 degree angle and draw a line from C dash. The intersection of this line with locus of D dash will be D1 dash, and this length will be our true length. Now as we have to find out the plan also and angle phi also. So if you want to find out the plan, we will get plan of point D on this projector and below the XY reference line, because we have assumed a point D in the first quadrant. So if you want to find out the plan of line CD, draw a straight line from D1 dash up to locus of C. The intersection of this line and this locus of C will be D2, and we can say that CD2 is our plan length. CD2 is our plan length. So measure CD2 and from C give an arc on projector of D. So we will get D over here. So this point will be our point D. Now draw locus of D. So this will be the locus of D and D1 also. Now connect D to C will be our plan length, and the angle of the plan length will be the angle beta. Now measure this true length on the rounder, put your rounder on C and give an arc on locus of D. So we will get D1 over here, intersection of this arc, and the locus of D will be D1. Now connect D1 to C will be our true length, and the angle of the true length will be phi. And as we have to find out the angle phi also. Now measure true length and angle phi. So true length will be equal to 105 mm and angle phi will be equal to 50 degree. Now let us move on to next problem. The end projectors of a line PQ are 35 mm apart. The end P of the line is 10 mm above HP and 15 mm in front of VP. The front view and top view of the line measure 50 mm and 60 mm respectively. So the front view will be 50 mm and top view will be 60 mm. Draw the projection of the line assuming Q in the first quadrant. Also find the true length and true inclination of the line with HP and VP. So first of all, given data. The end projectors of the line PQ are 30 mm apart. So EP is 35 mm. P is 10 mm above HP, 15 mm in front of VP, and the front view and top view of the line is 50 and 60 mm. So P is 10 mm above HP, 15 mm in front of VP, front view of the line is 50 mm, and top view, that is plan length of the line, is 60 mm. And we have to find out the true length of the line, that is TL, and we have to find out the true inclination of the line with HP and VP. The true inclination of the line with HP is theta, and true inclination of the line with VP is phi. So as we have to assume point Q in the first quadrant, so take the assumption, assume point Q in the first quadrant. Now first of all, draw XY reference line, mark end projectors. So end projectors are 30 mm, 35 mm, so measure 35 mm and draw the end projectors of the line at a distance of 35 mm. Now let us start with point P. P is 10 mm above HP. Above HP, that means the elevation of point P will be 10 mm above the XY reference line. So measure 10 mm from XY reference line in upward direction and draw locus of P dash. And it is 15 mm in front of AP. In front, that means the plan of point P will be 15 mm below the XY reference line. So measure 15 mm in downward direction from XY reference line and draw a locus of P. Now consider this as the projector of P. We will get P dash over here and P over here. So this will be the elevation of point P and this will be the plan of point P. Now we have front view, that is elevation length 50 mm and top view. And as we have assumed a Q in the first quadrant, we will get Q dash above the XY line and on this projector in upward direction, and we will get plan of point Q below the XY reference line on this projector. So now measure front view, that is our elevation length 50 mm, put your rounder on P dash, as we have to take this much of arc length, that is 50 mm arc length on the rounder, put your rounder on P dash and give an arc on this projector. So this will be our Q dash, join P dash Q dash will be our elevation length and the angle of the elevation length will be alpha. Now measure top view, that is our plan length 60 mm on the rounder, put your rounder on P and give an arc on this projector over here of 60 mm. Here we will get Q Connect PQ will be our plan length, and the angle of the plan length is beta. Now draw locus of Q dash and Q1 dash, draw locus of Q and Q1, because we will get Q1 on this locus also, and sorry, Q1 dash on this locus and Q1 on this locus. Now we have to find out the true length. So if you want to find out the true length, measure P dash Q dash and give an arc up to locus of P dash. This point will be our Q2 dash. Now from Q2 dash draw a straight line up to locus of Q. So we will get Q1 over here. Now connect P, Q1 will be our true length, and the angle of this true length will be phi. Now measure this true length on the rounder, put your rounder on P dash and give an arc on locus of Q1 dash. So give an arc on locus of Q1 dash, we will get Q1 dash over here. Connect Q1 dash to P dash will be our true length, and the angle of this true length will be theta. So now measure true length, theta and phi. So true length will be equal to 70 mm, theta will be equal to 30 degree, and phi will be equal to 45 degree. So practice these 3 problems, and after practicing that 3 problems, solve this assignment also. So this is it for today. Thank you.